is in this problem, if somebody said what is the nth term expression, we would write a sub n equals a1 plus n minus 1 times the common difference. If n is infinity, infinity minus 1 is infinity. Infinity times 3 is the common difference, is infinity. And infinity plus 1 is still infinity. So if n equals infinity, then a sub n also equals infinity. So that says that the nth term, so that last term, the nth term diverges because it approaches infinity. So we have that the infinite sum diverges because if we add up all the terms, we're going to approach infinity, and also the nth term diverges because if we keep going, eventually we'll have a term that's like infinity. Now let's compare this example to what happens down here. So down here, we might say arithmetic. We have a common difference of minus 6. So here if I talk about S infinity, I'll talk again about infinite sum. For our class we can think about that as series. And here if I add up all these numbers, I will get negative infinity. Because all these numbers are more and more negative as I keep going. So we would diverge because if we add all the terms, we approach negative infinity. Again, I could do the same analysis I did here. A sub n equals a1 plus n minus 1 times z. If n is infinity, infinity minus 1, still infinity. Infinity times the common difference is negative 6. Infinity times negative 6 is negative infinity. Negative infinity plus 2 is negative infinity. So all we're saying is if we keep creating new terms, at some point the new term will be like negative infinity. So in math we would say the nth term diverges. Let me take some questions on this though. Right.
Like, what's the example above that?
We will absolutely be getting there. Great question. Edgar.
So will we have like a question where it asks us like in this term is it
Does this subsequence converge or diverge?
Yeah. And what if it does have like 2 but it decreases? What if the numbers are positive? Then it'll
Like what? Give me an example.
like if it goes from a then 4 then 2, it'll still approach negative infinity?
8, 4, 2. So
Yeah.
like dividing by, so multiplying by 1/2. Like geometric
Oh.
or arithmetic.
No. Okay, so.
So like you mean like 7, 5, 3, 1?
Yeah.
I mean, but if I keep going, 7, 5, 3, 1, negative 1, negative 3, negative 5, negative 6, and keep going to negative infinity.
Oh.
So we can make kind of a rule here. Every arithmetic sequence diverges. Why is that? Someone answer, why does that happen? Why is it that every arithmetic sequence must diverge? Shanli?
It's because it's always either being added up to the added up to the next number or subtracted from the past number.
Keep going.
Both, so which one is it?
Yep. It's either going to go towards positive infinity or negative infinity. Now let's take some geometric examples and then we can answer Mariah's question, like when will a series converge? So let's take 3 geometric examples. Let's take example 1, and we'll call it 2, 6, 18, 54. Take example 2, which will be 4, negative 16, 64, negative 256. And then we'll take the last example, which is on the bottom of page 40 of the homework. So we'll take these 3 examples. Bottom page 40, page 4. Take the first one here. When I look at this, I see that r equals 3. So this is a geometric r equals 3. So the infinite sum here, the infinite sum, if I just keep multiplying 3 every time, my number will get bigger and bigger and bigger. So if I add them all up, I will get a very big number. So this will diverge, because the numbers keep getting bigger. And if I keep adding bigger and bigger numbers, I will diverge. Look at this one. R equals negative 4, R equals negative 4. So we're multiplying every time by negative 4. R equals negative 4. S infinity equals an infinite sum. If you think about this, these numbers keep getting bigger, either really big positive or really big negative numbers. Regardless, we will diverge. Because either we're going to go to positive infinity or we're going to go to negative infinity. It's one of the two. Now let's understand why this bottom sequence is different than all the other ones. Here we have an r of 1/7. This is the key, folks. If I keep multiplying by 1/7, the next term will be 1 over 49. 1 over 49 is smaller than 1 over 7. 1 over 7 is smaller than 1. 1 is smaller than 7. So the terms continue to get smaller. At some point, one of these terms will be eventually 0, or really close to 0. Which means if I were to add all the terms up, I would get some finite number. Because the terms are not getting super big. The terms are instead getting super small. So at some point, if I added them all up, I would get a finite number. This is an example of a geometric sequence that converges, or where the infinite sum, if you want, converges. So before we ask the final question, which is what does this converge to, let's ask ourselves why, or what the rule is for geometric sequences about converging and diverging. What is the rule? How do we know when a geometric sequence will converge or diverge? Anthony?
Convergence is
this has been the answer in every class, and in every class I have given this counterexample. So here, the r is 3/2, but this will diverge because these numbers keep getting bigger. Shanli?
It's divergent whenever it's either positive or negative number, and any other number is stronger.
What do you mean by any other number?
Like any other number that's not, that can be like identified.
So this is a number that can be identified.
So didn't you say that that's divergent?
Yeah.
Positive infinity?
Right.
Positive infinity is not identified.
Right, okay, yes. So converging does mean that the terms go to a finite number. But what can we say? How can we determine if a sequence will converge or diverge? You're right, like we can do that and we'll find out, but how do we know beforehand about a geometric
Because
sequence?
they're all the same, they have the same sign.
But these don't have the same sign and they diverge. Right.
Because like, okay, so the in the geometric sequence we want to find, now the like conversion.
Mhm.
R was something less than 1 and not 1, like R is still greater than 1 because R, 3 divided by 2 is equal to 5, right?
Right. So why is, I mean, you're right. Why is it though that if r is smaller than 1, we will converge? Why? Let them figure it out. Why? You're exactly right, but why is that the case, Mariah? Why? What is it? Let's be a little more specific. Edgar? Mariah's like 98.9% of the way right.
I was gonna say that like a number can't be, it has to be less than 1 but greater than 0, because if you keep dividing the number, or like if it keeps decreasing, it can never go to a negative. It'll stay in the positive.
So you're saying that if I had 1, negative 1/2, positive 1/4, negative 1/8, positive 1/16, here r is negative 1/2, this will converge so the numbers are getting super small. So the key, folks, is that if we have a fraction that is below 1, Brianna? If we have a fractional common ratio that is below 1, then each term, as Mariah was saying, is smaller than the previous one, so at some point one of the terms will be 0. And therefore the sum will be a finite number, as opposed to positive or negative infinity. So it's right there. If, and I'll write it as the absolute value of r is less than 1, then the series converges. And if the absolute value of r is greater than 1, then the sequence diverges. Now the question is, when we get to the last part, is so it does determine if the series converges, and if so, the value it converges to. So that's the last thing we want to do, is what value does this sequence converge to?